So I think we can start our interoperability framework web seminar. Just a quick information regarding questions that may be raised. First of all, by default, all participants are muted, but if you have questions, you can write down in the section of questions. And in this case, we will see that you sent us something. The other opportunity, you can raise the hand. So, and in this case, we will know that you have a question and we can unmute you and you will ask it. Okay, so I think we can start. So Ricardo, the floor is yours.
Thank you very much, Daria. Just one thing, I'm looking at, according to the panel here, there are 11 participants at this time, but I can only see a couple of them. So I don't know if the hand works. Would any one of you please raise the hand now to see if we can detect it?
Okay, you can just choose the tab attendees, and I see already that 3 people raised their hands, so it works, or even, yeah, even more.
Well, I don't see that, Daria, but in order not to waste time on this thing, if you see a hand raised, just tell me. And,
okay.
Okay. Well, thank you very much, everyone. My name is Riccardo Santoro. I'm the responsible for innovation program at Ferrovie dello Stato. But in this web seminar, I will be explaining to you, transmitting to you what this interoperability framework is, as a work package leader in one of, in fact, in 4 shift to rail programs. So I'm not talking as a Ferrovie dello Stato person, although the slide has the Ferrovie dello Stato logos all across it, but it's really a piece of shift to rail information that I want to give to you. Interoperability framework is a component of the innovation program 4 within shift to rail, which is concerned with I think the title is Smart Applications for Attractive Railways. But although it says railways, what we're thinking about is, of course, integrated mobility in general. So we went over the idea of railways. We're trying to build something that I will explain in a second, that really makes customers use the entire mobility network, at least in Europe, in a seamless fashion. I understand that today I'm speaking to many UITP members, so public transport is very much in your mind. And one of the things that I would like to achieve from this presentation today is to get input from you. This is the first time that I can talk to UITP members, not just the UITP organization, because this thing is at the beginning of, it's a research and innovation activity that is just beginning. There is much more that we need to do, and this is a good time to steer this thing in the right direction. So very much interested in working with UITP members. So let me move to the next slide, if I can manage to do so. I need to click in here. And I'd like to start by explaining what, not just us in Ferrovie dello Stato, but what at the shift to rail level, the joint undertaking, the European Commission, the many participants in shift to rail level, we're trying to achieve. This is a vision, if you want. This is not the purpose of the interoperability framework, but it's what we think digital mobility systems should be. Digitalization, of course, is very much in the scope. It is an enabling a transformational process, and in fact, the interoperability framework is exactly that. It's one of the things that enables us to digitalize operations so that we can achieve what you see on the screen. The point we were trying to make here with this slide is that people, actual living people and organizations are already digitalized in the sense that they conduct operations, they live their lives, they find services, they consume services, they produce goods and services in a digital world. This is already happening. So the main question that we try to the main gap that we try to close with the Shift to Rail IP4 program. It's not just the interoperability framework, it's a combination of multiple things. But the main gap we're trying to close is the disconnect that there appears to be now between the environment in which people actually live and the mobility system. There's a much better way to enable people to use mobility, much like they use telecommunications or many other services that are already digitalized. And the idea is the thing that is described in the picture below. The idea is that you use a device, any device. In here, it looks like a smartphone, of course, because that is the most widespread kind of portable device that you bring with you. But you can imagine any other kind of device. You use it to find solutions to your mobility problems. And this statement, I'll repeat it, is find solutions to your mobility problem. I'm not talking about tickets or plans or bookings. I'm talking about mobility problems, which, you know, an example may be, how do I attend a meeting? How do I go to class if I'm enrolled in a university, for example? How do I attend an event? These are the sort of questions that people have that normally we, at least we in the rail business, don't answer very well. We expect people to tell us where they want to go, where they're starting from, on which date they want to travel. We may offer a selection of different classes of service or options, you know, fast trains and so on, but we're not really asking, answering the questions, which may be, again, how do what can I do this next weekend with 200 euros and my children? This is not a question that we answer. This sort of questions people put to the internet, to the World Wide Web. And we know that we all use Google, which is just one, it's the main, but it's one of the search engines, to find answers to that kind of questions. We're not there. We are waiting for people to figure out that trains are an option, that there is a company that is called Trenitalia in Italy, for example, and then we're waiting for them to come to us after they made that decision. And of course, this is probably not what the digital mobility system is. So we're trying to achieve this. In other words, we want to be a company that knows how to solve mobility problems, so that what we sell is not a ticket, it's not a train, it's not a seat. What we solve is a solution to this problem. This is the goal. And of course, we're not even, we're just starting this journey. But we need to know where we're going if we're doing research. Now, what do we need to get there? Well, one of the things that we need to get there is to understand that when, let me go back here, when that mobile travel companion that you see on the lower left corner in the picture, when that thing is activated by a customer who has a mobility problem, who wants to know how to spend the weekend, for example, we need to, as a system, not just as a company, as the entire mobility system needs to be able to do this kind of computation. So you need to coordinate a number of very complex tasks that are distributed by nature. There are multiple services, there are multiple computers around the network that can do certain specialized tasks. But these are heterogeneous. These are sitting in multiple companies. Every operator have their own systems. And it is not just operators that are involved in solving this problem, because it may be, say, a service about the weather, a service about the availability of special facilities of the place where you want to go. So there are heterogeneous nodes that are connected in an open network that nobody controls. And this is important to understand. This situation is reality. It's not something that we want. It is the world as it is. So that we redefine interoperability. What does interoperability mean? Well, we say that systems and organizations are interoperable if they can participate in such tasks, if they can be found and provide their services in this very complex task. This is a huge challenge, but if you think of what you do every day when you're sending a query into Google, this is already happening. When you're looking for, let's say you're looking for pet food, let's say cat food on the internet, you don't have in your computer every possible data item, every possible web page from the internet. You don't download the entire internet into your computer in order for you to do this search. This data is sitting on the web, we say, which really means we don't know where it is. It is somewhere. There are computers somewhere around the globe that contain this information. And when you're looking for this for this particular item that you enter the query for, you get lots and lots of data in return that help you narrow down your search. You may be linking to another page, so going to another data set and examining this page and figuring out what to do next. And then you may even run a transaction, eventually even buy the pet food. This network is not controlled by anyone, in the sense that if you are, suppose you want to produce pet food, you know, tomorrow you start a company, the first thing you do, you advertise your services and products on the web. They go on the web without any particular control. You only need to respect some very simple rules as to how you annotate your content, how you tag your content with the HTML tags. And then every browser is able to interpret, and so that every browser in the world, no matter who builds it, can display this information. Now, we want to make systems, we want to enable machines to do what you do as a person. In other words, you can go to where the data is, you can examine the data, you can filter out the things that is not pertinent. You know what the difference is between a cat in the sense of a pet that you buy food for, and a cat in the sense of a lion that you don't buy a giraffe for him to eat. You know these differences because you have knowledge in your brain. We want to enable machines to have knowledge about the transportation domain so that they can do the same thing, that they can replicate the human intelligence when they do this. And then we say that the system interoperates if it is part of this world. And in fact, the World Wide Web can be taken to be a very good example of something that is interoperable. You can buy components at any shop, plug them in, and you know, turn it on, and you're interoperating. There is no particular complication in doing that. We want to achieve the same thing for the transportation network, knowing, of course, that we have a much harder problem to solve, and that is the machines are not as smart as humans. They don't have the knowledge that humans have. So that is the goal. That is what we're trying to do. It is not an interoperability problem by a technical problem. Interoperability framework is a concept. It's a research program that has developed some outcomes that are promising on how we address this specific problem here, which again is very hard. And we need to, you know, where are we starting from? If that is where we want to go, what have we been doing so far, and why do we need something different than what we're doing so far? I have here three essential items that qualify the current or conventional approach. And one is that we try to make it easier on us. You know, this is a inherently distributed network, which is open and under no control. We try to make it easier by removing heterogeneity as much as we can, just figuring out common formats and protocols and working on removing this one of these features, you know, which things are heterogeneous. Then, and this is another very important thing that we need to address, we make copies of this data. When we talk about data exchange, very often in the public, in the transportation domain, we very often talk about a company sending a data set to another company, so making a copy of data so that this data can be processed locally to the receiving company. And because we do this, we also need to limit the variety of these resources. We need to agree on the fact that, for example, these data sets that we copy are of a certain kind. There are timetables, there are fares, there may be something else, a list of stations, for example. But of course, we cannot, in a scheme like this, we cannot accommodate all types of resources that may be useful in figuring out or solving a mobility problem. So we are sort of self-limiting the scope of what we can do in trying to solve a customer's problem, a mobility problem. And as a consequence, we also generate a very huge problem on us, which is how do you control all of this? And therefore, we need to have a very heavy organization. It is necessary that we call governance in general terms, because now if you have data sets that are going from one side to another, then if you receive this data set, you need to have some means to ensure that you get it from a trustworthy source. And if you're sending the data to someone, you want to know how this someone is going to use it. Whether or not he's going to, whether he's authorized to use this data, for example. Then you need to make sure that the data that moves is synchronized, that everybody has an up-to-date, exact copy of the original data set. Then there's quality problem, you know, how do I know that the data is correct? And so on. All these problems are inherent with the fact that we make copies of data. So governance, in a sense, and this is a point that I'd like to make, is not inherent with interoperability. Governance is specific to the particular mechanism that you choose to do interoperability. If you try to do interoperability, as we've all been doing for years, which is making copies of data set, this data exchange mechanism that we've been using so far with common formats and so on, then we give ourselves a problem that is specific to this particular mechanism that is ensuring all these things that I mentioned. You know, my data is going to be used by people that I know. It's coming from people that I trust. It's up to date, it has good quality, and it's in the common format. All of this is a consequence of the particular mechanism that we choose. And to illustrate that, I'm going to show you what's going on in this particular case. The TAP TSI it means Telematic Application for Passengers, Technical Specification for Interoperability, and it is a regulation. It is a European level regulation. It is a specification that is regulated. In other words, it is a mandatory thing that mainline rail operators need to comply with. And it works like this. So you have these codes on one system. These may be codes that describe timetables of fares, special fares and stations and so on. These code lists are copied to the other system. So they are exchanged in the sense that they are sent to every other company. So they have supposedly, or in principle, they should have an exact copy of the same codes. And then there's a message that flows from one system to another, which is a way to organize. You can think of it as a telegram, where you put in codes taken from the code list, you send them across, and the other company, let's say system B, can extract these codes from the different positions in a message, look up their copy of the code list, and understand what system A wants you to do, okay? This is what is happening, and if you think of it, this is how ships at sea communicated, let's say at the time of the Napoleonic Wars. You know, you had the Admiralty would send a book of codes to every ship, And then ships will meet at sea and put up, say, flags, colored flags or lanterns if it was night in a certain pattern. The other ship will read these codes and figure out what the other ship was trying to say. Let's send me a carpenter, or let's all go northwest or something like that. Now, of course, this has inherent governance problems. If you think of it, if this is the Royal Navy, then you need to make sure that these code lists don't fall into the enemy's hands. You need to, if you're receiving, if you're reading flags from another ship, you need to know that these have not been, it's not the enemy trying to confuse you, and so on. So in fact, what we're doing now, and sorry for using a quite colorful example or analogy, but what we're doing now with this TAP-TSI regulation is not very different from what the Royal Navy or any other Navy were doing centuries ago, except that we're not using color flags anymore. We're using, then radio was invented. Now we're using the internet, but fundamentally the concept is the same. We're trying to do this. And this gives us a problem. In other words, let's say, it gives us a problem in the sense that it does not allow us to do what I said in my previous slide. Enabling the entire mobility system to be able to understand a customer needs and respond to a mobility problem. Okay, then of course this is TAP-TSI, and XML gives you a little more, this is an XML description of the same thing that you see here, but it's just a technical improvement that shows you that you have some tags there that some human can understand. This is a reservation request, but the point I want to make in here is that the things in black, the actual numbers, all of these are codes. Even the passengers number 3 there, it's a code. It doesn't mean 3 passengers, 3 individuals. It means a particular way of coding how many passengers want what kind of class in this thing. Everything else, except perhaps for the request date, is a code. So we're sending codes across. And it's extremely difficult to tell a machine how to interpret this and to keep everything straightened out. So what are we trying to do? This is probably the heart of the concept, the main concept in interoperability framework. It is moving from the 3 things that you see listed on the left to the things you see listed on the right. In other words, accept that formats are different, accept that the data is sitting everywhere. It's not, it is distributed natively, and it is inherently distributed. Every company have a data set, they have their own systems. And of course, because that implies centralized governance of formats and data flows, now we want to move to the right where we say, well, forget the formats. Let's machines, powerful machines that we now have, artificial intelligence can land rockets and things like this. Why don't we use them to say, let the machine figure out what the relationship between different formats is. So that's the first point. Let's make the heterogeneity of formats irrelevant to solving the problem. Let's see if we can do something to accept the formats are different but still operate. And we do that by abstracting from the representation in a way that I'll try to explain in a minute. So the other thing is that if data can be linked, in other words, if I can query the data wherever it is, if I can use the same approach that the World Wide Web uses, where every page, no matter where it is, can be linked to another page, and you as a user can navigate from one page from the other, why don't we allow machines to do the same so that data doesn't need to move, but it can be published wherever it is published? And that eliminates a lot of the governance problems, because if my data is not going anywhere, it's sitting in my computer, I'm the producer of the data, I have them in my machine, then I control who can come and get my data. I am in control of whether it's up to date or not. I am in control of its quality. And if I'm somebody who's looking for data, I'm going to the owner. So I know who I can trust, I know that the owner has the responsibility of the quality of the data. I'm getting it directly from him or her. Therefore, I know it's up to date. I know it's of the right quality level. So I'm easing the job of governance. We still need governance, of course, but it's a different type of governance. And I will discuss later on this ontology thing. So this is the heart of what we're trying to achieve. As I said earlier, we want to have this thing we call a cognitive hub. The mobility system is intelligent. It understands the customer requests. It can provide solutions by looking across the world. In order to do that, we redefine interoperability as the ability to make computation across the world, no matter where the data is, using all sorts of nodes that participate in the thing. And the way to do that is to go to the three things that you see listed on the right in this particular slide, okay? I'll try to address them. Now, it becomes a little technical, and I hope I can simplify it without trivializing it enough for you to understand. But of course, you're free to ask any question. I'm here to give you an opportunity to get this information. I'm not trying to tell you that this is the right way to do things. I'm telling you what we're doing, and we need your input and observations on this. So let's start by the first point. How do we make formats, the difference in formats, irrelevant? Or let's say not irrelevant, but treatable by machines so that we humans don't need to worry about it. The first thing is this. We create this thing that is called an ontology. The word is a little bit cumbersome, but it is a model, after all, of the world. It is knowledge about the domain. As in the example I was making earlier, you know, a human knows that if you're looking for a cat food on the web, you're probably not talking about a tiger. You're not looking for, say, a live cow to give to your pet tiger, because it's very unlikely that you have a tiger as a pet. This knowledge is not something machines have, it's something humans have. And we need to put this knowledge, and of course we're not talking about the simple case of cats, it's about domain, it's about transportation domain. We need to put this domain knowledge into the machine. And there is a way to do that. So it is a formalized and machine interpreted description of the domain knowledge. This is not the data. This is about the knowledge about the world. There is a way to do this. There is a standard. In fact, there are standards to do this. It's called Ontology Web Language. It's one of the web standards that we're using. And in this case, you have an example that says a stop place. Let's imagine that this is right. I'm not saying that this is the right model, but this is a model that I used to show you what I mean by that. We can say there is a thing in the world called a stop place that has relationships, like has a stop place code and is located somewhere, to other concepts. We have the concept of a location that has a latitude and a longitude. In fact, it may even have an elevation and something else. This location is the description of a point on the surface of the Earth. And I'm not speaking about any particular location. I'm saying every location on the surface of the Earth can be identified by two coordinates, which is latitude and longitude. And this is a true fact of the world that does not depend on what format you use to identify these particular instances. So it is true, and you can put them in there, you can put this knowledge in there as a statement, as a logical statement. The same goes with a code. Let's say that the code may have a type and a value. We say that this is a true statement of the world, no matter what kind of code you use, whether who assigns it or things like this. We simply say the things that have a code are described by these two properties in a particular case. So if we have something like this, which is just a list of axioms, the word for this would be axioms, then you can have multiple representations of the same fact, and there are a couple here listed at the bottom On the left is a comma separated set of strings and numbers. On the right is a fragment of XML, but they all mean the same thing. They're different representations, but we're still talking about the stop place thing. Okay, so the concept is that a machine, if it knows about the ontology, in other words, the formalization of the domain, then a machine can figure out that two different representations are equivalent and therefore map across these formats automatically. So the point about making formats irrelevant is not that we don't care about them, it is that we give the task to the machines. Machines are very good at doing this thing, and this is the first building block, conceptual building block in the interoperability framework. We're saying, let's formalize the domain knowledge in a way that is independent on how you represent the data in particular instances, and then the machines will be able to move from one format to the other, and this is no longer a problem. By the way, this is not very unlike some of the things, to this point, this is not unlike to what a trans model is doing. The trans model is a domain model. It describes domain and subdomains, let's say it describes routes, it describes pairs, and so on, but it doesn't specify a particular format for them. Now, it just so happens that you can generate XSD schemas or XML schemas from that model, and that is one representation. But in terms of a model, a trans model, that applies regardless of which particular data format you choose to use. Except for a couple of things that I will talk about later, which I believe are interesting, including for the transmodel people to develop further. So this is the first thing. If you can model something and describe the model to a machine, which is the important step, this model is not for humans to read. It is for machines to understand. That's why we say machine interpretable. Then formats become just processing. It's machines munching and eating bits and bytes, which they do very fast and they don't complain. So let's give this job to machines. That's the first thing. Okay. However, we're not using any representation for the ontology. Up there, we're using a particular standard. This is again a standard. It's called Resource Definition or Description Framework. It's another web standard. It's part of the semantic web standards. We're not doing anything that is not standard. I'd like you to get this. We are using standards that exist. And the interesting thing is that an instance of some concept, let's say in this case, an instance of a station. I haven't said yet that this is a station, but let's say the string on the left, for example, in the comma separated thing, an instance of, I think I should have a picture. Okay, here's an instance. I should have reversed the order of the slides, but here's an instance. The red things are the domain objects. In this case, the green things are actual instances. So we're talking about a particular thing. It's called Roma termini. It has specific instance of the stop place code, and it has particular values for those properties, code type and code values. And it also has particular values for those latitude and longitude. Of course, they're wrong numbers because Roma termini is in Italy, or these things is, I think they're close to England, some place, but it doesn't matter. The point is this is an instance. Now, if these instances that I'm showing here have a URI, a URI is a universal resource identifier, which can be a URL, in other words, a web address. In other words, the Roma termini identifier that you see in this slide is a URL. In other words, it looks and feels and operates like a link on a web page. And this allows you to link these resources in a web of resources, which is very much like a web of pages that you find on the World Wide Web. This is why we say in our interoperability framework lingo or jargon that What we're doing is building a web of transportation data. In other words, we're taking the data wherever it is, we're putting it into this particular representation, which is RDF, which again is a standard. And by virtue of the RDF specification and features, we now can link this data across the world and build a worldwide web of data, just like we have a worldwide web of pages. This means that you don't need to copy the data anymore. I'll give you an example here. I'm afraid this is a little technical, but the thing you see on the top right is a query. It looks like SQL for those of you who are familiar with databases, except it's not SQL, it's called Sparkle, and it's a particular language that is used to perform queries across the web. And in this example I'm giving you, the query here is find me the code types and code values of something that is located in that particular location. And the important thing or message that I'm trying to give you here is that the green things can be sitting in any server across the world. Like, sorry, I need to take a drink of water just a second.
Yeah.
And it's just like your pet food store can be on a web page, and then the catalog of cat food can be on another page, and you may be sitting across the world, and you're still looking at the World Wide Web as a single database. This is the idea. So if you can build this thing, now you can write an application that uses the entire World Wide Web of data, of transportation data, to perform tasks like journey planning. By the way, I forgot to, to say this, but the Interoperability Framework is not an application, it's not a journey planning application, it's not a selling application, it's not a ticketing application, it's a piece of software that completely masks the complexities of interoperability so that you can build applications of your liking, you can build any sort of application, taking the World Wide Web of data as granted. It's just like you would write an application today, and you take the internet for granted. You don't program every single port and every single bit and byte when you're writing an application today, because all of that is taken care of by the internet protocols. With the Interoperability Framework, we're using the same model. You build an application using this World Wide Web of data. You don't need to worry about how that happens, because there is an interoperability framework that helps you do that. So that is the thing. Now, to give you an example, to give you a real life example of this query, I have created one very quickly. Perhaps I can come here. You should be able to see my my screen here. This is a query that I was showing earlier. This is now, as you see here on the top, this is the address of the Interoperability Framework triple store, which handles part of the Interoperability Framework mechanism. And I say, I want to know what the code type and value is of some stop place that is sitting at that particular location. And you see the location it looks like, in fact, it is a URL. In other words, it could be anywhere on the world. If I run this, I get this information. So I say that, you know, the type is UIC, the code is this code that you see here. In fact, I may even ask, if I now inspect the link, I discover interesting things. For example, I discovered that it is a rail station. Now, if you look at the query itself, it doesn't say that. You don't know whether this is a rail station. It could be a bus station. It could be something else. But once you get the URL, because URL is a URL, you also know other things. For example, you discover in this case that it is a rail station. Now, this is very simple. There's much more power than this, of course, but this is the minimum I can do to show you what is going on. In other words, and here's the point, let me go back to my presentation. The point is that it doesn't matter where the data is sitting. You can go from one element to another. In fact, what we're doing in the Interoperability Framework is using this, exploiting this capability, as I will show you in a second. Now, here, I want to discuss now, I said earlier, the ontology is a model of the world. And transmodel is also a model of the world. Very good people, very smart people have been modeling the world, and they know much more than I do about public transport in particular. They have captured information about the world. Now, what we're doing in the interoperability framework is something similar, but we're using a specific language. Because as I said earlier, the problem is that we want this model to be known by machines. In fact, not just known by machines, but interpretable by machines. So we went a little step forward. And again, this is a complicated thing to explain, and forgive me if I become too technical, but I'm trying to my best to make it as simple as I can. In this particular case, and unfortunately I didn't have time to redo this for this particular web seminar. This is it's an Internet of Things domain, but it doesn't matter. The principle that I want to show you is that unlike class diagrams in UML, when your domain model is described in ontology web language, in OWL it's pronounced, then you can do things that are a little more powerful that you have expressivity for in the XSD or in the UML semantic, and that is provide statements, create axioms or statements that allow the machine to do a little more than just convert from one format to another, but it can also find additional information as entailments, as logical consequences of the axioms. In this particular case, we have the statements above in black. These are axioms. In other words, this is not about data. This is about domain models. And I'm saying that a sensor provides measurements. This is a statement, a logical statement. And the measurement it provides for a sensor whose identity is X, let's call it M. We say that a thermometer is a type of sensor. So it's a class of sensor. It is a sensor like others. Oops, sorry, something popped up on my screen. Okay, and then we have another axiom that says if the sensor is a thermometer, then the measurement is a temperature. Okay, these are true things, true statements of the world. It doesn't matter what technology you use and what kind of thermometer you use, and this is true for every sensor that is a thermometer. But now, if the machine knows about this, then it can create an additional information. Like in this case, it can infer that the temperature, that what the measurement in case this 001, because it's coming from a sensor, which is a thermometer, is a temperature. And the interesting about this fact is if it is a temperature, then the unit of measurement is now constrained. This cannot be kilograms or liters. It's a temperature, so it must be degrees. It must be Reaumur or Celsius or Fahrenheit or Kelvin. But this thing is not, it is now constrained. In other words, from the fact that you have axioms, so your domain model is not just class diagrams. It is a set of logical statements written in a language that looks like XML, but it's really first order predicate logic statements. If you have these axioms, now a machine can reason about that and generate additional facts. Now, I'll try to give you an example of the real thing that we did in what you're seeing now on the screen is a tool called Protégé, which is used to edit and to test ontologies. In other words, the kind of thing that I was describing earlier. This is not the IT2Rail ontology. It's a very small subset that I created for the purpose of this presentation, to try and explain what is going on. Now here we have a definition. You see the thing that is highlighted. This is a railway station. I'm saying that the railway station is a subclass of the operation domain. This is just simple statements. But here's what happens now if I start the reasoner. In other words, I apply now a piece of software, it's called a reasoner, to the ontology, to the OWL file, which is something you cannot do to a UML diagram. This is the additional capabilities that you get if your model is described in OWL instead of UML. And that is, if I start the reasoner, then I find a lot. It's going to take a little while to do a number of things. Now you find a number of interesting things. For example, you find, just a second, I did something stupid here. I need to go back here. Okay. You see down here a number of instances have appeared, which are classified as rail stations. And you have here, for example, airports. The thing has also found airports. And how did it do that? Well, it did it because let's take Charles de Gaulle. Charles de Gaulle, let me stop the reasoning for a second. We said that Charles de Gaulle is an instance of something which is located at a place that you see here, and it is located in Paris, and it has a stop place which is called CG railway station. This particular thing is defined in such a way that if you start the reasoner, I'm getting in trouble because it's not easy to explain all this thing. This thing now is classified as a rail location. If you want to know why that is, the tool can tell you how it achieved that particular statement. I'll try to keep it simple. Let's say 4 particular inferences that have been done. Now it says here, for example, let's take the first one. It says that Charles de Gaulle railway station is the end location of this Mont CDG. And the Mont CDG here says that it's something that is the object of a property that says operate links. But if something operates a link, and which is a train, then the route link is a rail link. And if it's a rail link that ends someplace, and this is a rule that is here, that is done in here, then it's a railway station. Eventually, this is a railway station. And this is how this particular rule was able to determine that Charles de Gaulle is a railway station. Now, I don't know if I was able to show you what I'm talking about, but the point I want to make is simply this, that by using this particular way of describing the domain model, I can leverage the capability of machines of performing inference. What is really happening is theorems are being proved from the axioms, and you can generate, in fact, the machines can generate additional information. It can find and discover additional information. One of the things, for example, maybe it's in here. For example, if you look at vehicles, let's say that I'm looking for flights, it discovered that these things are flights and these things are trains, which when I stop the reasoner are not even listed there. I'm saying that the vehicle that has a transportation rail is a train. This is an axiom. Now, if I start the reasoning, it will find things that are trains. Okay, like this one. Okay, so coming back, so what is the message here? I try to show you, and it's not easy to describe an ontology because it is really formal logic, and you need tools to do that. By the way, there was a question by somebody, is there a Word document explanation of the ontology? The answer to that is yes, you can do that, but you will never actually get the meaning because this is really a machine-readable set of axioms. So you need specific tools to work with them, which are the ones that I'm showing down right here. So coming back to my presentation, the point that I was trying to make is that by the fact, I need to select this. Okay, But the fact that you had statements, logical statements in your domain model, now the machine can generate extra facts and including constraints on the values that certain properties can have, which are logical consequences. This is not code that you write, that humans need to write to limit these things, but are actual things that have been discovered by the machine. So we put together two things here. If you have a domain model which is an ontology, then you can create this sort of inferences. The second is, if this representation is in RDF, then you can link the data. Now you have a world wide web of data on which you can perform queries and discover data, which are logical consequences of the information that you put on the web. And this is the heart of the principle of how the on which the interoperability framework works. This is not the interoperability framework. It is the fundamental concept that we're using. And as you see, this is totally different than organizing common data formats and exchanging data sets. Okay, if this is a concept now, how do we actually implement it? Well, the interoperability framework is a piece of software that fundamentally consists in the RDF lifting and lowering framework that you see here. By lifting and lowering, we mean the operation whereby a message or a piece of data in any format is converted into a graph, into an RDF logical graph, and how this logical graph is then converted back into any other message format. The things that you see colored in here are linked. This is why we called it a web of data, as I explained earlier. So in creating a format, the output of some process in any format that you want, you have the entire World Wide Web of data available to you to generate this message. And you can link a lot of external graphs. They exist. In fact, this is, in a sense, these are the building blocks of the interoperability framework. You see on the right, you see that we're using these external triple stores, this DBP, the FAT4s. These are data that exist already. You can go and look them up on the World Wide Web. We have our own triple store. It's a repository. When I ran the query earlier, when I was showing you the code values from a location and discovered that it was a rail station, I was using this triple store. And then the interoperable services are all packaged into a set of tools that I will describe in a moment. Everything is managed through this thing we call the asset manager. The asset manager is an application. It's a piece of software that we use to manage, let's say, linking the pieces together and making sure that we're using good data and so on. You have an ontology editor, which is the one that I was showing earlier, this protégé editor that allows you to update and work and debug the ontology. And you have an annotations editor, which is the one that links the data representation, a specific data representation, to the terms in the ontology.
Riccardo,
okay.
we have a question regarding IT to Rail ontology. So the question is, when will the IT to Rail ontology be online? Right now, it seems not to be at IT to Rail website.
It is already online. It's been for a long time. In fact, let me. But I will say something about that. Give me a second because I want to go to the asset manager. This is the asset manager. I'm going to sign in. Can you see the screen? Yes, you can see the screen.
Yes.
Okay, among the assets here you have the IT2 Rail ontology. As you see, you can download it. And of course, when you open it, you're going to need Protégé. The file looks like this. Let me wait for it to open. Can you see it? Okay, this is a file, but you cannot read this file unless you use the Protege tool. You need, Protege is one tool. It's open source. There are many others. Some of them are commercial, very, very powerful and so on. But the ontology is there. As you can see, I just downloaded it from the Asset Manager. This thing has been online for a long time. So the ontology is available. However, let me qualify. Let me be clear about this. This IT to Rail ontology is not a definite domain model. It is the thing that we started working on in the beginning of the interoperability framework. As I said earlier, interoperability framework is an ongoing research project. It's not by, it's organized, of course, in projects, but the interoperability framework concept that I tried to explain so far is not something that is finished because we created one IT to Rail ontology file. In fact, as I was you can see on the screen, if I can go back to the screen here. Let's look for ontologies. Where are they? Yeah, ontologies. Okay, there's also a start ontology, which is an extension of the IT to Rail ontology, because this has been another, and this again can be open and clicked and reviewed and versioned and everything. So the tool is there to help with this editing of the ontology. So these ontologies are there. They have been there for a long time. They can be made available to anyone who has the credentials. All I need is to have your user ID and password. You can come into the Asset Manager and get it, but it's not complete. So it's not complete, it's not even close to being complete, because of course this is an ongoing project, and we continue adding things, removing things. And in fact, now I'm going to step a little bit out of the presentation I'm making, but my personal opinion is that this thing should go in the hands of people who do this for a living, which is not a rail company. So I would be happy, and I said this already at some meeting, if the ontology was taken up by a group like Transmodel or whatever, provided this is an OWL ontology. I don't know what to do with a UML ontology in the interoperability framework. So I hope that answers the question.
And we have another question
yes.
from other person. Probably this question is related to the publicity of the asset manager. So what is the URL for the asset manager? The link you used is an IP address, and I can't find it.
You can see it on the top here. I'm highlighting it. You see on the top, I'm using a web browser, and you should be able to use the same browser. Now, this is a 1373 and so on, because this is not yet, let's say, available on the public internet. But you should be able to access it. Of course, you would need a certificate and so on. But this thing is a web application. In other words, you can download this ontology from anywhere. What you need is the URL, and you need credentials. That's all. It's not a complicated thing. I hope this answers the question. The question was, as I understand, where is this asset manager? Well, it is at this address that you can see on the top here. Can you see that?
Yes, yeah. I think we all can see.
Okay. Yeah. So that's where it is. And again, this is an experimental thing. We're not claiming that this is ready for the public in the world to use it, but it's there, and it's designed precisely in such a way that the ontology can be shared. People can work on the ontology, and then I think we will have to talk about this. How do you subdomain it, and how do you make it modular? And a number of questions about how do you handle the ontology. Well, the ontology, the asset manager is just a tool to help you. For example, in this case, there's a version, and you can. It's associated with a life cycle, which goes into from being a proposal to being reviewed and being released and versioning and so on. It's a workflow that allows you to govern, in fact, to manage this kind of development of the asset. So the ontology, and both the asset manager and its content are available for people who have the credentials for it. And again, the point I want to make is this is not a complete or a final version of any ontology. It is the things that we did to fulfill the requirements of the projects and the brief of the project that we have been working on with so far. Does that answer the question?
Not at this moment, but the last comment was from the same person that he would like to get these credentials to access the asset manager. So my question is, can we send him because probably I have the login and passwords, and can I share it with the participants?
I don't think you have the user and password of this asset manager. You can share it, but the fact that we have a final conference this coming Friday. And one of the things, this does not belong to me. It is not I who authorized this thing. This belongs to the Shift to Rail undertaking, joint undertaking, and joint undertaking. And there are some issues about the intellectual property sort of thing. I think they can be solved very quickly. You can get the credentials. This will work for me. I will give them to you right now. But this is not my property, so I need to check this with the joint undertaking. But I think it's something we can solve by Monday.
Okay, great. So at this moment there are no questions, but I just remind you that you can raise your hand if you have question and to ask your question, or you can use the section questions where you can write your question.
Okay, now I want to, as fast as I can, I've talked about the principle. I showed you what the ontology is, or try to explain you what the ontology is, or how it works and what it does and how we used it. Now I want to show you, in fact, let me go back to that previous thing. What I want to show you is the thing that you see at the rightmost, the right bottom, this interoperability framework services, okay? The asset manager, the editor, the annotation, the triple store, this is everything this is the fundamental blocks of the interoperability framework. But then, on top of it, on top of this technology, we build specialized services that to do something very specific, in particular to handle certain conversions of data and so on. I want to quickly show you a couple of these examples. These are this is a tool called SOAP UI. It's a tool used to test web services and RESTful services. The interoperability framework is a collection of web services. These are also available. In fact, these are not even protected by credentials. You can use them today. And I'm going to show you, first of all, a couple of things. In fact, let me start with the travel expert broker. Let's say, so how do we use the interoperability framework in a real situation? Okay, let's say that I want to look for. This is a sample request. This is in a particular language. It's a format that has been defined. You see AMA here by the company called Amadeus. So it's their particular way of making a request to see. This would be a shopping request. There's a passenger that you see here who wants to go, I believe, from I don't even know where he wants to go or travel. There's a particular date that he wants to travel. It's on the 26th of, this is a very simple request for what do you have available for me. Now, if I click on this and send this request, hoping that the network is up to there, I get this response. Let me enlarge it as much as I can. Oh, by the way, this is technical. This is not a selling application. This is just showing you what a selling application would do. So this is not the logic for doing journey planning or anything. It's simply an application sitting at the Amadeus company that is interrogating some other company to see what they have available between those places. And you see here, in the particular format that Amadeus expects, you see here a number of possible solutions. You have, you know, subway, U2, I think this is Unterbahn, you know, the thing in Berlin. The service provider is somebody called Berliner Verkehrsbetriebe, and so on. And yeah, somewhere, if I continue going to see, there are a number of possible solutions. Here's an offer, for example. It's a fair basis. It says here that it's a Regeltarif, Tickets für die Verbindung from Potsdamer Platz to Flughafen Berlin-Schönefeld. And there is a price. I think there is a quotation here. It is for 13 euros and 20. Yeah, because there are 2 decimal places. And the condition is says here that, oh, there's another one for Schüler. I think there are school children and so on. So in other words, here are a bunch of possible offers that the shopping application can combine with others. And this is coming from live. This is a live service. It's coming from Berlin, public transportation. This is not an emulation. This is a real thing that you would get if you were going to their journey planner and see where can I go, and so on. We can do another of this. Let's say that we're interested in going from Prague to Berlin on coaches. I think, yeah, this is coaching, a long distance. Okay, so you have coach station in this case. And you have, for example, this thing is about senior for over 60 years, and you have a quotation in multiple currencies, I believe. Yeah, you have 1530 euros, or it could be 410. I think this is Czech crowns, and so on. In other words, you're getting information about a long distance coach company. We can also try to go, let's say, from Grenoble to Bordeaux. Let's see if the date is correct. Yes, still Friday. And let's see what this will be going to the SNCF system. There you go. And so you see there are stations, and you know, Lyon. I think you need to go through Lyon to go from Grenoble to Bordeaux. And yeah, and to Paris. I can see that also. And here are there are many options. In this case, you can, for example, this is product. You can go first class, AC, I think, being seated with a flexi, and I think there were 2 people. Therefore, there are 2 products, and here is the total is 350 euros in first class AC. But every passenger, first passenger pays 283, the other 67, I believe, because one is a child. Let me see. Yeah, one is an adult and the other is a child, and so on. In other words, I'm showing you that this thing is working. This is the SNCF system, and the SNCF system. I show you 3 things. I could show you the others, but I show you 3 particular requests. One is going to a public transportation consortium in Berlin. The other is going to a set of companies that do long distance coaches, and the other is going to a mainline operator. And these are the real systems that we are calling. This is not an emulation. These are the real systems that we're calling. And these companies, this is an outcome of the IT2Rail project. These companies did not have to change anything in their systems. Nothing. Zero. They're all using different services, different formats, of course. One is JSON. It's not just the format that is, or the structure is different, but even the language. One is JSON, the other is XML. One uses basic authentication, the other uses tokens. So the product is also different, but as you see, without any change on their part, they can now participate in a combined multimodal shopping organization. But this is not it. It's not just the end of it, because we decided to redo the same thing by using a different format. Let me do again the Prague to Berlin thing, but this time the request is in the FSM format. FSM is a specification that has been developed together by mainline operator and some global distribution systems like I think Amadeus. There was also Travelport and other companies. And so it's a different specification. It's not the Amadeus specification, but I'm still calling this. And now I get the same result, but this is a different format. And in this case, I'm calling the AMS, this travel shopper, we call it, travel expert, we call it. And as you see, the format is different, but it contains the same information. These children, I think we were looking at seniors or something like that. These are different things. You have the price, except that in this particular specification, I cannot have multiple currencies. So in this case, I have to get, I can only show the euro, not the Czech crowns. But, you know, it's the same thing. And we can go from Lyon to Paris, I think, with the same specification again. And again, the systems that I'm calling are live systems, in fact, are the same systems that I called earlier, but with a different format, and they still can respond without any change. So I'm calling the same travel expert, SNCF, BBB, you know, public transport, mainline, it doesn't matter. I'm calling the same services, and without any changes on their part, we can use multiple formats. So I'm trying to tell you that this thing about formats are no longer relevant in the sense that machines can figure out how to move, how to copy, how to map from one format to the other is real. It's been achieved in the IT2Rail project. And in fact, there are other services. Let's say Netex. Okay, in fact, let's start with this location solver thing. Let's say I'm interested in knowing, oh, okay, how do I go to the UIC, the International Unit of Railways headquarters? You know, I want to go there. So, you know, what kind of places, you know, what kind of, is there a way to go there? Let's see what this returns. Okay, it says that there is a rail station called Champ de Mars, Tour Eiffel, that is at 211 meters from the place, which has this latitude. It has a code here. But I could also take I think this is a subway station, which is a little farther away, 260 meters, and it's called Bir Hakeim, and blah, blah, blah. In other words, we have means to interrogate this triple, so this web of data to get information about, you know, what is closest and what places, what stop places do I have available to travel to where I need to go. And this would be used then by the travel expert broker that I was showing earlier to make the request. So you first figure out what station is closest to where you want to go. And as you see, the name, let's do something interesting. Let's say that we want to go to the astronomical clock, guys. Astronomical clock in Prague. Let's see what it says. Yeah, okay, here you have the Stratos, Domenska, whatever, subway station, and Nustek, and you have the distances and so on. And you can do the same thing in another format that happens to be Netex. Let's say, let me see what request I have. Let's say I want to find, this is about finding stop places around the box. I think it's, yeah, it's a bounding box that is Rome, I think. And you see, you have, here we go. This is the Netex format. It is a composite frame that contains frames and a side frame. This is Villa Bonelli with codes and so on. Longitude, latitude is telling you what the public code is, what transport mode it is, what stop place type it is. In other words, formats are not a problem. We can work with many formats. And not only that, I don't need to have this data in my computer. This is all coming from the web. So I can interrogate this thing, find the nearest station to the astronomical clock in Prague or whatever, without having data local to my machine. I simply go and interrogate the web. Then we did something more and said, let's make it more, make it harder on us. Let's try to do this thing with TAP-TSI. The TAP-TSI, as I said earlier, is a regulation specification for mainline operators. There's one transactional message, it's called a reservation request and reply. We did it, and let's say that I want to, let's take the request. It's a birth request. So the TAP-TSI request, according to the regulation, would look like the thing you see here. You see something strange. A requested train has a train probably number, but this is, in other words, this is not something that I made up. This is a regulation specification. Let's see. I want to convert this to the equivalent. I can click on this. And here it's the same request, but this time is on the right. You see it is in the FSM specification instead. Right? So, and by the way, the system in here, you have the codes of the, say, departure station 83, and this thing is also returning something else in addition to that, which is the geo coordinates. And the reason is that it's looking through the web. It's getting more information that you would get from a standard TAP-TSI sort of thing. So in other words, the principle that I tried to describe earlier are in operation now. This thing is in operation now. Now, so I show you a few things, and there are others that maybe I could also show, but we're running out of time. Unless you want to see more, I would return to the presentation. I want to say one thing. What you just saw is stuff that is in operation, but is by no way ready for being, it's not industrialized, okay? For example, there's no security around this. There is no backup recovery. All of these very important items that that you need in an industrial application or thing are yet not there, because we are still expanding it. Just last week, we were awarded a new grant for a new project. It's called Sprint, that is going to continue developing on the interoperability framework. But it is enough to, as a technical demonstration. In other words, it shows that the principles that we are using actually work. And in fact, and this is private to my company, in Ferrovie Stato, we're now putting it to work in a real industrial environment. We're building all the the security, the recovery capabilities, the thing that you need in an industrial operation. But this is still under development. So I want to summarize what you just saw. So given that you have an asset manager that contains resources like the ontology, and you have editors to update the ontology and to annotate the classes, the messages in whatever format, and the ability that you now have, because you're using the RDF and so on, to go and link data wherever it is and so on. Now we could develop some interoperable services, the thing on the bottom right that you just saw in operation, that achieved these things that we wanted. The first is we can work in multiple formats with multiple operators without these operators having to change anything, and I mean zero, to their systems. Not only that, I can call the same, let's say SNCF, sales and reservation system, with different formats, and it's the same operation that responds me in these different formats without them changing anything. And the other thing that you saw is that there is no data that is copied from one company to the other, because the data, including the computation of the actual charges that you need to apply to your customer, are performed at the owner of the application. So the SNCF, for example, the SNCF company is not giving me a file containing data that then I use to compute the price. It's giving me the computation of the price, including if they want the discounts and whatever it is, the logic that they use. So we have reduced the cost of interoperability, as we are trying to achieve, by making the formats irrelevant, or which means, again, giving a job to the machines. And the second is by limiting, in fact, eliminating the copying of the data, which means that you now have a much more focused and lighter governance architecture, the organization, because what this governance needs to worry about is what we want governance to worry about, and then that is, how do you keep the ontology green? How do you evolve it? How do you make sure that you accommodate additional requirements? How do you do that? And that is where we want organizations to concentrate on, not worrying about whether data has to be sent on May or June, or who gets it, or how do you regulate all of that. So that is essentially the principle and operation of the interoperability framework. This is just, yep.
Ricardo, there is one question.
Yes.
How do you link data based on different ontologies?
That is a very, very good question. Today, we're doing it with humans who understand the data. The Sprint project that was awarded just last week is about automating this, adding the ability for machines to at least determine candidates. We're not sure we can totally automate the thing. You will still need some human who can do some in-depth analysis of stuff. Machines can do theorem proving, but to a limited extent. So in the Sprint project that is now starting, we will be addressing exactly that. At this time, for example, the fact that an entity in our triple store is the same entity as in the DBpedia is something that we discover by simple means of, for example, are they within 5 meters of the same geo coordinates? That gives us some candidates, but we cannot trust that to be completely accurate. In fact, we cannot trust DBpedia at all, if you ask me. But we now need to do, and we have this research project that is now starting to do that, is how do you discover mappings across ontologies? And how do you discover, therefore, mappings between instances of ontology concepts across the World Wide Web? It is one of the extensions that we need to do.
Okay, and Ricardo, we have just 5 minutes left.
Yes.
Yeah. Can you summarize the conversation?
Yes, I think. Yeah. Let me see if I spent a lot of time. Well, this is about just the same. Oh, by the way, I just wanted to finish by saying that the principle, of course, does not apply to one particular domain. It applies to many domains. It depends on what you're modeling, what ontology you're modeling. This presentation that I gave you is an adaptation of something that I'm already doing on the Internet of Things. And this picture shows you that the Internet of Things specialists are thinking along the same ways. In other words, they are trying to go to a semantic web of things, which would be the equivalent of what I call the web of transportation data. But the principles that apply are the same, the standards that apply are the same. And in fact, there is a lot of activity going on, particularly in the W3C consortium. You see here, this is W3C. It's called the Sensor Network, Semantic Sensor Network Ontology. This is managed by the W3C consortium. And you see there are subdomains and so on, and there are multiple things that are happening. There are applications and so on. So this is just to say that we did not invent this. We're trying to apply this thing to the transportation system because, and here's my recap, because the ultimate goal has nothing to do with the interoperability framework, but the ultimate goal is that the mobility system as a whole becomes intelligent enough that it can work not as a journey planner, not as a ticketing thing, not as a booking a platform and so on, that it can work as an intelligent agent that you trust and that you can go to when you have a mobility problem. It will answer. The tool to do that is the travel companion, but the mobility system as a whole will, this is the future thing that we see, will be able to understand and answer and provide you with options on how to solve your mobility problem. In order to do that, we need to solve a complex technical, scientific, engineering challenge, which is making computations across an open network of heterogeneous nodes. And therefore, we use semantic technologies to do that. We use an explicit specification of the domain knowledge, which is logical. It's not just UML, it's OWL, which I think everybody in your organizations can use. Requires just a little bit of training, which gives us the ability, and this is the first thing. The second thing we use is the RDF, which gives us the ability to link data across the web. The combination of the two things gives us a World Wide Web graph of inferred information that then we can use machines to automate into whatever, the transformation into whatever format we want, so that we can build applications. Everybody can build applications using their own native specification if they choose to do so, and seeing the entire World Wide Web as their database. And that is and I also show you a few examples of the thing in action. And this is what I wanted to describe to you.
Okay, great, Ricardo, thank you. So at this point, we don't have any questions, but I remind you that you can type it in the section of questions or raise your hand.
I'm making a note that I will be requiring whoever needs to give me this approval that these credentials into the asset manager should be shared. So I will make it my task to get you the credentials.
Okay, great. Thank you. So no questions for now. So it means that our time ran out. And thank you for attending. Thank you, Ricardo, for giving this presentation. Okay, thank you.
Thank you all. Thank you very much for your patience. Bye-bye.